Okay, so we'll go ahead and get started. So I guess before we start these notes, just a reminder, today we're doing our CUDA review, and I guess I'll go over it a little bit more after, and that's after our notes, we'll do some example problems for more notes. And then because your test is on Thursday during class. All right, so. A piecewise function is a function that uses excuse me, different rules for different parts of its domain.
Wait, Miss Rice,
Yes.
is that the first part of the stuff? Is the stuff above him part of the notes too?
Oh no, that's from last time. That was our two variable inequalities.
Okay, I just want to make sure. Thank you.
Uh-huh. So we'll just do an example. Sketch the piecewise function. And then find the domain and range. So here f of x is going to be equal to 2 to the x if x is less than or equal to 1, and 3x plus 1 for x is greater than 1. So your piecewise functions, remember, they're written as a bracket. It can be 2 pieces, 3 pieces. It could be 7 pieces if we wanted it to be. And all of the step functions we've done in the past, those are actually piecewise functions. We just don't usually write an equation for them. So again, the way we're going to do this is, since there's 2 pieces, we're going to set up 2 tables. Our first one is x, and then we're going to evaluate 2 to the x. And this is when x is less than or equal to 1. So we want our table to stop at 1. And then our other table is x, and then we're evaluating 3x plus 1. This is when x is greater than 1, so we start at 1. We have big numbers that are greater than 1. Okay, so doesn't matter which one of these we fill in first. So 2 to the negative third, I just want to kind of remind you guys real quick, 2 to the power of negative 3. It's a decimal, but if I make that a fraction, that's 1/8. Remember, negative exponents are the same as the reciprocal. They're flipping it. 2 to the third is 8. So 2 to the negative third is 1/8. 2 to the power of negative 2, same idea. It's 1/4. 2 to the power of negative 1, that's 1/2. Anything to the power of 0 is 1, and 2 to the first is 2. And then if you look at this table and kind of think back, way back to math 1 in our exponential equations, this 2 is our multiplier. So we're multiplying by 2 to fill in our table. Or if we went backwards, we're dividing by 2. All right, and then here we plug in 1. 3 times 1 is 3, plus 1 is 4. 2 times 3 is 6, plus 1 is 7. And then again, we know our growth is 3. And then a couple of things before we actually graph this to remember. This point right here for this top equation is going to be a closed circle. The reason it's closed is because it has or equal to, and then this point here is open because it's just greater than. It doesn't have the or equal to. So again, I just plot all of these points, and when I get to 1, 2, I know it's a closed circle. 0, 1, negative 1, 1/2. And we know what an exponential looks like, and so we know that this goes like that. And if forever it has that asymptote. And if we don't know, we should know that from Math 1, as well as we took notes on that earlier this year. And then 1, 4 is here, open circle, 2, 7. The rest don't fit. That's okay. We know it's a line. And then the second part here says find the domain and range. So domain is everything we can plug in for x. So we can keep going in the negative direction for x and in the positive direction. So here our domain is all real numbers. Our range is where it gets trickier on this problem. You won't see a range problem this hard on your test yet. I just wanted to make sure we had a hard one in our notes. So range is all the y values. We can see from our graph, it's never below 0. It's never negative. It also doesn't quite hit 0 because it has that asymptote. So this piece of our graph goes not quite to 0, but all the way to 2. So it's 0 is less than y is less than or equal to 2. And for this piece of our graph, it starts at 4, but it doesn't quite get there. So it's and y is greater than 4. And it goes up forever. So again, you won't see one, like I said, this hard on your test Thursday, but it's good practice. Do we have any questions on that before we move on to our examples for your worksheet?
Yeah, I have one question.
Yep.
So for the graph, instead of like all I have to do is just plug in numbers to the x's, right? To find those numbers.
Mm-hmm.
Okay, that's all I want to know. Thank you.
Yeah, just make sure wherever kind of this endpoint is, that's where you start or stop your table.
So if the x is equal or greater than like 5, I would want to stop the graph at 5.
You'd want to stop your table at 5 for your x values. Yep, yep, perfect. Okay. So this is our chapter 3 review notes. So number 1, I'm just going to kind of abbreviate the directions. We're going to try to determine if this is even or odd or neither, or both. So the equation is f of x equals negative x squared plus 3x plus 3. So we're going to go over both algebraically and graphically here. So to graph this, again, a couple of things. You can either do it on Desmos, you can do it on your graphing calculator, you can plug values into your table. I'm not going to scale my axes. I'm just going to kind of show you guys what the graph looks like here. So again, that's just a sketch of the graph. So from the graph, remember, if it's even, it's going to have reflection symmetry across the y-axis. So if I reflect this across the y-axis, this vertex is going to end up over there. It's not going to be the same vertex. So it's not even from the graph. And then if it was odd, if I turn my paper upside down, it would look the exact same. And this doesn't. Now we have a parabola that opens upward. So it's not odd either. So from the graph, it's neither. Again, if it's even, it has that reflection symmetry. You can fold it on the y-axis and it lands on itself. If it's odd, you can turn it 180 degrees around the origin and it lands on itself. So it's neither. And then to do this algebraically, we plug in negative x So negative x, when we square it, that part becomes positive. This negative still stays out front from your order of operations. So that's negative x squared minus 3x plus 3. Since these are different, this tells us it's not even at least. Again, if it's even, f of x is equal to negative f of x. And then it's odd if negative f of x equals, oh, I wrote that backwards. Let me wipe that out in just a second. That should be a negative inside the parentheses, sorry. So it would be even if f of x is equal to f of negative x. Those weren't the same. It's odd if negative f of x is equal to f of negative x. We just did f of negative x. Now we have to do negative f of x. Remember, that's just you put a negative in front of the whole entire thing and switch all of your signs. Basically distribute that negative. So we get positive x squared minus 3x minus 3. So here we're checking, does negative f of x equal f of negative x? And we see that these are different. That's negative x squared, that's positive x squared. So it's not odd just from that piece. So together, those tell us that it's neither. So again, that's how you do it on a graph. You check the reflection symmetry, you check the rotation symmetry. Algebraically, you plug in f of negative x, and then you check negative f of x. Okay, so number 2, we have the square root of 7r plus 22 is equal to r plus 4. So on this problem, the directions are going to say check for extraneous solutions. Remember, that means when you plug it in, does it work? So to solve this problem, we're going to want to square both sides so we can get rid of this square root. So over on this right side, we have to make a box. And on the left side, the squared and square roots are going to cancel out. That's why we chose to square it. So 7r plus 22 is equal to r squared plus 8r plus 16. We have a quadratic because our highest exponent is r squared, or a squared, a 2. So we get it equal to 0. Zero equals r squared plus r minus 6. From here, you're either going to factor or do the quadratic formula. By now, we all should know how to solve a quadratic. If you need help reviewing that, feel free to stick around after this, and I can go over that with you. But if I factor this, this becomes r plus 3 times r minus 2. And so I'm going to get r equals negative 3 and r equals 2. And so we have to go back and check our solutions in the original problem. So here I'll check negative 3. And here I'll check 2. So if I check -3, I have the square root of 7 times -3 plus 22. You're asking yourself, is it equal to -3 plus 4? So -21 plus 22, I get the square root of 1 is equal to 1, 1 equals 1. So that works. On the right-hand side, we're checking this other one. 7 times 2 plus 22 in the square root, is that equal to 2 plus 4? So 14 plus 22, I get the square root of 36 is equal to 6. 6 equals 6, so that works. So both of these are solutions here because both of them work. Okay, so number 3 is solving graph. It's an inequality. So -4 minus 4 parentheses 6n plus 1 is less than 136. Okay, so remember to solve inequalities, what we're going to do, we're going to pretend like it says equals and just solve it as if it were an equation. So here we distribute, so -4 minus 24n minus 4 equals 136. -24n minus 8 equals 136. So I distributed and I combine like terms. Add 8 to both sides. -24n equals 144. And then when I divide that, I get n equals -6. So here at -6, I have my circle. Sorry, paper got turned. And it's open. It's an open circle because this didn't have an or equal to. So remember now you have to check to see if we should shade the right side or the left side. I'm going to test 0. You can test any point you want as long as it's not that boundary point. -6 is our boundary point. So if I check n equals 0, or test it, I should say, I have -4 minus 4 times 6 times 0 plus 1. Is that less than 136? So in my parentheses, I get 1, so I have -4 minus 4 times 1. less than 136. Negative 4 minus 4 is less than 136. Negative 8 is less than 136, which is true. So that tells us we shade where 0 is, since it's true. And then remember to write your inequality. So it's not n equals negative 6, it's n is greater than negative 6. Because these numbers are larger than negative 6. Wash my hands here. I can see you over there. You're okay. Okay. So number 4 is solve with square roots, solve by taking square roots. This is a quadratic. We could use quadratic formula if we wanted to. The directions say to do it otherwise. Anytime your middle term is missing, if your b value is 0, you can do it by taking square roots if you want. So the first thing we would do is just add 5 to both sides. 3m squared equals negative 14. We have to get our m squared or x squared, whatever, alone before we can take a square root. So we divide both sides by 3. We get m squared equals negative 14 over 3. And here's where we square root, now that we have our m squared alone. So m equals plus or minus the square root of negative 14 over 3. But there's a problem with this. This is the same as the square root of negative 14 over the square root of 3. Those are just properties of square roots. You can do the numerator and denominator separately or in one square root. The problem with this is we can't leave a square root in our denominator. So we have to multiply by our big 1. It's going to look funny, where it's going to be root 3 over root 3, because that's what's in our denominator. So this becomes plus or minus the square root of negative 42. 14 times 3, 42. The negative's still there. And then square root of 3 times the square root of 3 is just 3. Or the square root of 9, which we know is 3. And last thing, we cannot leave that square root inside, or sorry, that negative inside our square root. And we could have taken this out of the first step. It doesn't make much of a difference as long as you do it at some point. We know if we have the negative inside there, it becomes an I, and the rest can stay. Root 42 over 3. So here it says use the information provided to write the vertex or graphing form equation of the parabola. So it tells us it's a parabola. The equation is 2x squared plus 4x plus y plus 5 equals 0. So the first thing you want to do on a problem like this is you want to get y alone. Again, y, we want to be positive y. So since this is positive, I'm going to take the long route and I'm going to subtract everything else. If you subtract y, that's fine, but then you just multiply both sides by -1. So our equation is -2x squared minus 4x minus 5. Again, this isn't graphing form. Graphing form is going to have our a, h, and k in it. So we still have to do some things here. So in order to do this problem, we have to complete the square. So what you want to do first to complete the square is you want to get the x's alone. So I'm going to move the 5 back to the other side. Personally, some people don't move it in the first place. You like your x's on one side and everything else on the other side. I like to see what the equation looks like first, but if you don't feel the need to do that, that's fine. So we have y plus 5 equals -2x squared minus 4x. Since a is not 1, we have to factor it out. So you're doing your distributive property backwards. Basically, you're dividing this by -2, whatever a is, and I get x squared plus 2x. This is plus 2x, because if I divide -4x by -2, I get +2. I'm doing 2 squares because the 2 in front, it is negative, and we'll talk about that in a minute. So x squared, I split my 2 x's in half, so that's x and x. These have to be the exact same or you did something wrong. So our squares are both missing a 1. So inside my parentheses, that's like writing a +1. But what I'm really putting on the other side is -2. The reason it's -2 is because you have to multiply this -2 times 1. So it's -2. So y plus 3 equals -2 times x plus 1 squared. The reason we added 1 was to write it as the outside of the box. Then last step, subtract 3 on both sides. So y equals -2 x plus 1 squared minus 3. So to remind you, that means the vertex here is -1, -3. This problem didn't ask for that, but you should know how to identify h and k. And we have two more. Give a second before I turn the page. The next one is also writing graphing form, but it's for a circle, not a parabola. X squared plus 20 minus 20y equals negative 2x minus y squared. So for a circle, it's kind of the same idea. You want to get your x's and y on one side, and then your constant, your number on the other side. So we want to move the 20 to the other side, and we want to add 2x and y squared. So x squared plus 2x plus y squared minus 20y equals negative 20. You can do this in 2 different steps if that confuses you to do it all at once. And when you get it, the x's and y's on one side, you want your x's together and you want your y's together, because you have to do 2 different squares for those. So for my x's, since it's just 2x, I cut that in half and I get 1 and 1. Y squared, half of negative 20 would be negative 10y. So then you complete the square for your x's and you complete your square for your y's. So our missing piece for our x's is 1. So I want to add 1 to both sides of my equation. And the missing piece for my y's is 100. It's positive 100. Negative times negative is positive. So I'm going to add 100 to my y's, or both sides of my equation, I should say. We added 1 here to make this x plus 1 squared. That's the outside of the box. And we added 100 to make this y minus 10 squared. Negative 20 plus 1 plus 100 is 81.
No.
After I finish. So just to remind you, the center of this equation would be negative 110. And the radius would be 9, because you take the square root of 81 to get the radius. And last problem, it's just graph the inequality. Y is greater than x squared plus 4x plus 3.
Hey, Mommy, you make the name. I was thinking if I had a name.
So so if I just make an XY table here,
The tiger one. Why I wear diapers?
here, watch something on here for now.
No, where's hospital?
I don't know. So if I just plug in -3 squared plus 4 times negative, probably would have been quicker without my calculator. -3 squared plus 4 times -3 plus 3, I get 0. Plug in -2. Just gonna copy that and change those. I get -1. Zero again. I should know when I plug in 0, I'm going to get 3 because that's my y-intercept. 1 squared plus 4 times 1 plus 3, I get 8. We can keep going. I'm not going to. That's already not going to fit on my graph. So if this is 0, 3, I also know on this left side, I'm going to have a y value of 3 because it's a parabola. So a couple of things before we kind of finish this. Do not just connect all of these. Remember, this is going to be dashed because it doesn't have or equal to. And then we have to test a point that's not on our parabola to determine where to shade. So we can test anything as long as it's not on that dashed line. I always recommend 0, 0 if you can. So if we test 0, 0, we have 0 is greater than 0 squared plus 4 times 0 plus 3. This is a question. We're checking this. 0 is greater than 3, which is false. So 0, 0 is here outside of the parabola. Since this is false, that tells us we shade inside the parabola. Because 0, 0 is outside the parabola. So 0, 0 is outside. That was false. That means we shade inside. All of these points in here are solutions. And you don't cross your parabola. You can cross your axes, just not your parabola. And that's what that inequality looks like. So you have your CUDA works now. It has problems similar to these. That is your homework. Remember, this CUDA works is due on Thursday by 10 a.m. That's when we're taking our test in class. Since it's a review for your test, it needs to be done before your test. Everything else will still be due on Monday. So tomorrow we'll start chapter 4. If you have questions from chapter 3, from the review, anything about the test, bring them tomorrow, please. Unless you have them now. I'm happy to stay and answer questions now. But that is all I have. So you can get started on this, and I will see you tomorrow at 10 a.m. unless you need to ask questions.